Hey, welcome to Voltage and Currents in Circuits. So we've already looked at what the two quantities are in either case. And what you're going to want to be able to do now is combine the flow rate and the energy change in the construction of circuits. So we have some basic schematics here. This is an amp meter. That's a voltmeter. Light bulbs can be shown in a number of ways. A resistor with a circle around it. AC voltage, ground, DC, pretty straightforward. We don't bother with LEDs, but I've included it because they're replacing these, and so you should start learning what this means. Okay, you need to be able to compare sources of energy to ladders or escalators elevating electrons to a higher level and loads draining the electrons on their way back down. So a battery, a voltage source, is a stack of plates that functions like an escalator, and the loads are areas where your total energy changes. You convert your energy from height, if you were a skier, to speed. If this was a wire, you change your voltage to heat, and you lose voltage on the way down. You need to be able to explain how the nature of a current or flow requires interfering with the traffic to measure it, but measuring energy change is done by bridging a change in energy with a device. And the example is this: if you want to count people going down a conveyor belt, you must put the counting device in the traffic. And many of these turnstiles have the habit of stopping old people who aren't strong enough to push them. But if you want to measure a change in elevation, a ruler must span the difference. And that's why tape measures were invented, because sometimes the height difference is so long, you need a step ladder. So you can measure flow at a point, but voltage has to be measured between 2 points. A basic circuit, same word, circus, circle. You have a source. We may have a controlling switch, a load, and back to the source. If this were shown as an example, this would be it perfectly. The source allows you to increase in energy. There's a gate preventing you from flowing. And then if you close this gate, you can go down and you go around and you go back up and you go down and around and back up. And I go across and I go down and I go back and I go, and you go in a circle. You got to know that basic circuit. Now, what if we were to measure current and voltage change through this circuit? Well, let's see. To measure the traffic, we have to put a meter in the circuit itself, in the actual flow, and the electrons will push it like a revolving door. And unlike little children, they won't keep going around in a circle. They'll go through, flip it, and keep on going. But if we want to measure the energy change, the voltmeter is connected across an object. So notice there's no way for the flow to go around the meter. There's no connection here. But on a voltmeter, the flow that goes through the bulb, there's actually a little bit of the flow that has to go this way to be measured. So a voltmeter actually sips off a little bit of the energy. So when you connect up a voltmeter, you should technically see the light bulb dim very little as it goes this way. But voltmeters are designed to interfere as little as possible, but they do create a new pathway around the circuit. So let's look at it this way. There's the battery lifting our energy. The electrons are counted as they pass through the turnstile, but there won't be any flow if the gate's in the way. The flow will only start when the switch is closed. Then the electrons go surging forward and they fall in altitude. Oh, cool. It was like a tadpole. Okay. And that fall in altitude has to be measured at 2 separate points. Okay? You can't hold a ruler to your head and say, look how tall I am. It's got to go from the feet to the head. So this circuit is represented by this analogy. Now, what happens if we have several loads in a row? Well, it's like having several ski hills in a row. You get lifted up by your energy source to a certain voltage. But the ski hill, instead of going all the way down to the bottom, there's a drop, and then there's an area where no change in drop occurs, and it drops again. Now, if you go up 100 meters on a hill and you drop vertically